Hey guys, welcome back to the Machine Learning Intermediate course part 1 by Life Changes Academy. So in the previous session, in the beginner videos and all, we will be learn what machine learning is, also how different algorithms works. So now it's time to move into the next level. That one is data pre-processing as well as future engineering. So guys, before we train any machine learning model, there is one important step every data scientist follows. That one is the data pre-processing. In fact, many people think that building the model is the hardest part, but surprisingly most of the work happens before the model is even created. So in this today's session we are going to learn about the data pre-processing concept as well as feature scaling, feature engineering, and then what is encoding and so on, right? So without any delay we will start the session. First of all, we are going to learn about data pre-processing. Okay, what is mean by data pre-processing? In the word also contain, that is the processing. That means it contains some process. Okay, step by step actions, right? Yes. So I'm saying some example. Okay, so that you guys all remember this concept. So guys, just imagine. Okay, you are cooking your favorite dish. Okay, so before cooking, do you immediately put everything into the pan? All the fruits, all the masalas. Likewise, you don't add everything in the same pan before cooking, right? So first what you do means you will be washing all the vegetables, right? And then you will be removing the spoiled parts, and then you will be cut everything properly, and then you will be going to start cooking, right? It will be having some procedure, that means some process, right? So the same idea that is applied to the machine learning also. So here the raw data, the previous messy, that one is like a messy. Okay, the raw data is usually messy. It will be looks like a messy. Why I'm saying messy means it will contain some missing values, or else it will contain some duplicate records, and then it is not in a correct format. Okay, and then it also contains some incorrect information and all. Okay, so before we will be giving data to the machine learning model, we will first clean the data and we have to prepare the data. So this process is called as data pre-processing. Okay, data pre-processing is nothing but the process of cleaning as well as preparing the raw data before we will be giving it to the machine learning model. Okay, so for example, you will be imagine a school wants to predict the student exam marks. Okay, so the data set contains like name, the student name, student age, and then how long the student studied. Okay, the particular person will study for 6 hours, 7 hours, that study hours, and then student attendance as well as student mark. Okay, these are the columns. Okay, so but some student forgot to enter their age, right? So when you're asking student to fill the Google sheet, means some of the students will enter all the details correctly, some of the students are forgot to enter their age, some entered attendance is 90 percentage, others entered just 90 alone without any percentage, some even left the study hours empty. So can we directly train the model? Of course not, right? So we must first clean the model. We want to clean all those problems. You will be entering the data correctly. You will be check the data whether the student has 90% attendance, or else whether the student fill all the fields. Likewise, you have to check. Okay, so that concept is called as data pre-processing. Okay, so why it is most important means, so why this concept is very important in today's environment means, there is a famous saying in machine learning is, that one is garbage in, garbage out. Okay, this one is a famous saying in the machine learning. What it is means if you I'm saying one example. Wait, I'll move to the next one. So here the golden rule, garbage in, garbage out. What this is means, like if you give in any poor quality data to the machine learning model, means it will produce the poor quality predictions, that means poor quality results. Okay, even the world best algorithm cannot learn from the bad data. Okay, so imagine, okay, if you are asking Google Map for directions to reach your destination, okay, but the map contains wrong road information means, will it guide you correctly? Of course not, right? So the same thing that is happen in the machine learning also. So the good data, that means the good information, that is leads to the good predictions, that is good results, okay, and then the bad data will automatically leads to the bad predictions, okay. That's why pre-processing is one of the very most important step in the machine learning pipeline, okay. So good pre-processing gives you as a better accuracy, faster training, as well as reliable results, okay. So when you are giving the data to the machine learning model, mean it should be in a correct format without any errors, without any mistakes, okay, so that it will be learning the data properly and it will be giving you the perfect predictions, okay. So this is how the pre-processing will be work. Next we are going to see handling missing values, okay. Now, let's look at one of the most common problems. That one is missing values. So, guys, just see the example data set, okay? So, here the Priya's age is missing, right? Can we leave it like that? No. Why? Because means the model does not understand the empty values. So, we have four common methods to fix the missing values, okay. The first one is remove the record. You have to completely remove the record Priya, okay. If only a few rows have missing values, right, not every students will enter leave the rows empty. No, not like that, right? So only few rows are missing and we will be simply delete them, okay. Suppose we have 1,000 student record means only 5 records are incomplete means remove those 5 records. It won't affect the data set much, okay. So second one is use the average. That means fill it with average. That means suppose the ages are here, see the ages 25, 30. So it will be the average. So some ages are 20, 25, 30, 35 means the average age is 27, right? So 27.5. So we will be replacing the missing value with some average value. That means our predicted value will be entered in the particular column, okay. So this works well for numerical data. Then third step is most common value. So imagine you are storing gender, okay, that one is a female or male. You will be filling those details means imagine you are storing male, female, male, female. Most students are male means, so if the one value is missing, no, that particular value will be replaced with the male, okay. So this is called the mode. We already studied in our school day max, mean, median, mode, right? So that concept mode we will be also studied in the schooling time. So that concept only applied here. Most common value, we will be applying the most predicted result, okay. And then predict the missing value, predict it. That means sometime instead of guessing, we let other machine learning model estimate the missing value. So this is how the model will be predicting some average age to the particular person. So this is more accurate for the large data sets, okay. So this is how we will be handling the missing values, okay. So next we are going to see that encoding categorical data. So now let's move to the other most important concept. That one is encoding categorical data. So what does this mean? Machines understand the numbers, right? They don't understand the text values, right? So for example, imagine you have some colors, okay, that means red, blue, green to us. These words make sense, right? So for us, we will be knowing that what is the red color, what is the blue color, what is the green color. We guys know, humans know that one, but machines Obviously it doesn't know about the colors and all. Okay, so for the computer and all, it's just a text. Okay, so we convert them into the numbers. Okay, how means that process is called the encoding process. Okay, for example, red means we will be assume it as one, number one. It will be identifying only the numbers only. So we will be numbering to the particular colors. Red means one, blue means two, green means three. Likewise, we have to encoding the data. Likewise, male, female means 0, 1. Okay, so now the machine model also able to understand the data. Okay, one means we will be showing the red color. When user click two means it will be showing the blue color. Likewise, it will be identifying the data and it will be giving the predicted result to us. Okay, and then another one is one hot encoding. Okay, sometimes for example, simple numbering is not enough. Okay, imagine cities. Okay, like Chennai, Delhi, Mumbai. If we assign Chennai 1 means Delhi 2 and then Mumbai 3. Okay. So the model may incorrectly think Mumbai is greater than Chennai. Likewise, it will be assuming, okay, but cities do not have any order, okay. The first city, second city, likewise, no order, okay. All the cities are same only, but so that we will be using that one hot encoding, okay. One hot encoding is nothing but it will be assuming that each city has its own separate column, okay. This avoids the confusions, okay. So that only we will be using this one called encoding. Okay, so next we are going to see feature scaling. So feature scaling means nothing but it's like a future engineering concept behind this. Okay, so guys, just imagine two futures. Okay, age is equal to 24. Okay, this example, age is equal to 25 and then salary is equal to 50,000. Okay, so which number is much bigger? Obviously salary, right? So because salary is much larger value. Okay, comparing to 25, 50,000 is the larger value, right? So the model pays more attention to the salary than the age. Okay, that's unfair, right? So we scale both future to similar ranges. This process is called feature scaling. Okay, so this contains two methods, that means two solutions. One is normalization, another one is standardization. So normalization is nothing but it will be converting all the values into their range between 0 to 1. That means 10 means it will be become 0.1. 50 means it will be become 0.5. And then 100 means it will be become 1. Now every future has a similar scale level, right? So this one is called normalization. It will be normalizing all the values between 0 and 1. And then standardization. Standardization is nothing but it will be changes the data. That means mean becomes 0 and then standard deviation becomes 1. Okay, so many machine learning algorithms are perform better after the standardization. Okay, so what are the benefits? Means it will be giving a better accuracy and then it will be giving a balanced learning and then faster training. Okay, next we are going to see that feature engineering. So this is a important concept. Okay, so future engineering. Okay, instead of using only the existing data, we create a new or else more useful features. So, for example, suppose your data set contains only date of birth. Instead of using the birth date directly, we calculate the person's particular age, right? So age is much more useful than date of birth. Okay, that's the future engineering. Okay, suppose we have this timestamp. Okay, so the timestamp means it will be having 15 June 2026 means 15 June 2026 9:30 a.m. Instead of using the entire timestamp, we will be split into day, month, year, hour, and then weekday. Now the model can discover better patterns, right? Another example is salary to category. So some person salary will be 18,000, 20,000, 42,000. Instead of exact salary, we create a categories. That means low income, medium income, high income. Okay, sometimes these new feature improves the model performances. Okay, and then feature scaling. Now next we are going to see for another concept, that one is a feature scaling. So just because we have many features doesn't mean we should use all of them. Some features are useful, some are completely unnecessary. Imagine we are predicting the house prices. Okay, so useful features include area, number of bedrooms, location, which year the house will be built. But what if the data set also contains it will contain owner's favorite wood, door handle brand, wall paint color. Does these affect the house price? Not really, right? Keeping unnecessary features only confuses the model. Okay, so that only we have to remove that one, or else we have to modify that one. This process is called feature scaling. Okay, this will be most faster, and then it is one of the simplest model, and then it will provide the higher accuracy also. Okay, next we are going to see that why data quality matters. Okay, so let's first understand one final concept. That one is the data quality. Think of building a house. Okay, so if the foundation is weak, means the entire building becomes unstable, right? Similarly, machine learning model also depends on the high quality data. I mean, good data, good futures. Okay, good data only creating the good futures, which build good models. Okay, which produces the good results. Okay, everything start with the clean data. We already seen the data pre-processing concept. That process only providing the clean data. Okay, so this is how the quality data matters. Okay, so next we are key takeaways. Okay, key takeaways is nothing but we will see in these concepts: data processing, missing values, encoding, feature scaling, engineering, and then selection, and then data quality, right? So better data always leads to the better machine learning models. Okay, so guys, thank you for joining in this intermediate session. So keep learning with these concepts. Okay, remember, building a machine learning model is important, but preparing the data is even more important. Okay, so in our next video we will be continuing the next intermediate level concept in the machine learning. So I hope you enjoyed this session. Also, you will understand every concepts clearly. So keep learning and then keep growing with Life Changes Academy. And then thank you so much for watching. I will see you in the next video. Happy learning, guys. Thank you.